right, let's continue our discussion with lesson 3.6, which is exponents and scientific notation. And this time we'll be focusing on scientific notation. Now, before that, just a quick review. When we have positive exponents, okay, it tells us how many zeros follow after the number 1, okay? So again, when we talk about powers of 10, these are numbers that when you raise 10 to an exponent, all right? So if we have the example here, 10 to the 9th power, we have the number 1, okay? And then this exponent here, because it's positive, it tells us that there will be 9 zeros after, okay? Remember, this is going to be after 1, okay? So in this case, that 10 to the 9th power would be 1, 2, 3, 1, 2, 3, 1, 2, 3. So this is now read as, so this is thousands, million, so 1 million. Sorry, 1 billion, I should say 1 billion. Because this is to the 9th power, okay? Now, when we have negative exponents on the powers of 10, that will tell us the number of zeros, okay? These are the number of decimal places to the right of the decimal point, okay? So when we have negative exponent, that thing means it's going to be a smaller number, okay? It's going to involve decimal. If you have a positive number, this is going to be a large number, all right? So if we have negative exponents, so this will be 0 point, okay? There should be 9 decimal places before you hit the number 1. So that would be, let's have it here. So you have 1, 2, 3, 4, 5, 6, 7, 8, and then 9th is your digit number 1, okay? So that's a total of 9 decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many zeros will there be? There's gonna be, let's use this one. So you have 1, 2, 3, 4, 5, 6, 7, 8. The 9th decimal place is the digit 1. Okay? So please bear in mind that when you have positive exponent, it's gonna be a bigger number. All right? You will have zeros to the right of the digit 1 or to the right side of the digit. If you have negative exponents, you will have decimal places, and that is being talked about. That's the number of decimal places after the decimal point. So why do we have to talk about this? Well, when we say scientific notation is another way of writing either very large number or very small number, okay? So when we have a scientific notation with a positive exponent, okay, then it means it's gonna be a greater value, all right? So remember, scientific notation could either be to rewrite a very big number, okay? So when you have a very big number, this is when you have a positive exponent, or a very small number. When you have very small number, that is when you will have negative exponent, all right? So that is pretty much what it says here. So if your n, the power of 10, is a positive, you just move the decimal point n places to the right. If it is negative, then you have to move it to the left, okay? Now, one thing that you have to remember about scientific notation is that whenever you have scientific notation, it is always written with 1 digit and then a decimal point, and then it could be several digits here. There should always be only 1 digit to the left of the decimal point, okay? You cannot have, let's say, 35.4 times 10 to the 5th power. This is not allowed, okay? It should always be just the digits 1 up to 9, okay? So it will always be, this first digit should always be any number from 1 to 9, Okay, you can have as many decimal places afterwards, but the first digit, this one, should only be one place, one digit only. So, for example, on this case, we have the scientific notation, which is written as 1.375 times 10 to the 10th. Okay, so let's go back here. We have 1.375. Now remember, when you have a positive exponent, which is here, positive 10, we are moving this decimal point 10 to the right. Okay, so we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we fill out those zeros. All right. So when we write our scientific notation in decimal form, this would be, so you have 0, 0, 0, comma, 1, 2, 3, 0, 0, 0, comma again. And then you have 750, and then 1, 3. So this is actually 13,750,000. Okay? So remember, positive exponent, you move the decimal point 10 to the right. Now, our next example, we have 1.1 times 10 to the negative 4. Okay, so we have 1.1. Since our exponent is a negative number, so it's going to be 4 decimal places going to the left. So from here, we will go 1, 2, 3, 4. So the new decimal point is going to be here. And we fill out the blanks. 1, 2, 3. We have 3 spaces with 0. So our final answer in decimal form, okay, in decimal notation, it will be 0.30 and then the numbers 11 at the end. So that is how we can convert scientific notation to decimal notation. All right. Now, if it is the other way around, if you have a very big number or a very small number, then you will have to count again the number of decimal places, okay? So, take a look at our first example. Always remember that when you have a very big number, then the exponent will be a positive number. Now, we have 4,600,000. Is this a very small or very big number? So, because we know that this is a big number, then we know it's going to have a positive exponent. All right? So how do we know? Now, always remember, you should only have one digit. So you have your decimal point, okay? Sorry, your point. Okay? There should only be one digit to its left. And in this case, we want the decimal point to be between 4 and 6. So we have 4, and then this is 6. So to make your decimal point to be here in between 4 and 6, how many movements do you need to make it a 4,600,000? So you are going to have 1, 2, 3, 4, 5, 6. So that is going to be 4.6 times 10. Because this is a big number, that would be a positive 6 exponent. All right? So 4,600,000 written as a scientific notation is going to be 4.6 times 10 to the 6th power. Now, let's take a look at our next example. 0.00023 is a small number, okay, because of your decimal point. So we know that this is going to have a negative exponent, all right? So this is going to be what? So we want the decimal point to be between the 2 and 3, okay? So we want it here to be between 2 and 3. So this is going to be 2.3 times 10. So how many decimal places do we need to move to get in here? So that will be 1, 2, 3, 4, 5. And because it's a small number, so this is going to be 10 to the negative 5. So that is how we work with changing decimal notation to scientific notation. So can we also do operations with scientific notations? Definitely. So when we are multiplying or dividing our scientific notation, we work with the number, okay? We multiply them as they are, and then what do we do with the times 10 to the something power? Now we are going to apply the rule for the exponent. So if we have the same base 10, all we need to do is add the exponents together. So for example, in this case, 3.4 times 10 to the 9th, we have to multiply it with 2 times 10 to the negative 5. So what we will do is multiply 3.4 and 2. So 3.4 times 2, this is going to be 6.8. Now looking at our exponent, 10 to the 9th and then 10 to the 5th. So remember, it's going to be 10 to the 9th minus the exponent, which is negative 5. And if we're going to apply the rules of subtracting integers, we change the sign and then we add. So basically what we have now is 10 to the 14th power. Okay? Oh, sorry, my bad. We're not subtracting. My bad. Let me erase that part. My bad. So we are supposed to be adding. My bad on that one. Let me correct myself. So we are adding the negative 5. Okay. So 9 plus negative 5, that will give us 10 to the 4th power. So if MATLAB is asking for the scientific notation, it will be 6.8 times 10 to the 4th power. But because the question is asking us to write it in decimal notation, then it will be 6, 8, and then we will have, so from here, 1, so you have 1, 2, 3, 4, so you have 3 zeros afterwards, so that would be 68,000. Okay, so that's how we work on that. Again, if we are having division, so we just work on the number part, and then we subtract our exponents. So in this case, we will have 8.4 times 10 to the negative 7 divided by 4 times 10 to the negative 4. So we know that 8.4 divided by 4, this is going to be equal to 2.1. Now, when we have our exponent, 10 to the negative 7 minus, okay, this is the one with the minus negative 4 because it's division. So reminding ourselves with the subtraction of integers, we change the sign and then we add. So this is going to give us 10 to the negative 3, okay? So our final answer will eventually be 2.1 times 10 to the negative 3. But if it is asking for the decimal notation, so we know that there should be 3 decimal places to the left, to the right of the decimal point. So you will have 1, 2, 1, 2, and then 3. That is the 2 and the 1. So remember, from here, it's gonna be 1, 2, 3. Okay? So our final answer is 0.0021. And that is how you work with exponents and an application of it, which is the scientific notation. Thank you.